콜카타에서 학교하시고 지금 카이스트에 와 계시는데 2월에 이제 뭐 유니버스 레지나 캐나다로 가서 공부하신답니다. 제목은 T to the T cobordism of quasitoric four manifolds. 네.
Thank you very much for the introduction, and I would like to thank the organizer and Department of Mathematics of KAIST. And I am also very sorry that I cannot speak Korean. Okay. So, yeah. I would like to discuss about the cobordism of quasitoric for manifolds. Okay. So, beginning of the conference, we heard about the definition of quasitoric manifold by St. John, and so I want to skip that definition. And here we will consider Tn equal to S1 power n. Okay. And so in the title we have two terms, T2 cobordism and quasitoric manifolds, and I will skip the definition of quasitoric manifold, and let me recall the definition of T2 cobordism, or in general Tn cobordism. So suppose M1 and M2 these are Tn manifold, that means it has effective Tn action, and also M2 is an Tn manifold, and both are orientable. Okay. So if there exists and suppose the dimension is M, if there exists a manifold W of dimension M plus 1 such that it has boundary with two components, one is this and other is this one, which are one of them is equivariantly homeomorphic to MM and other is equivariantly homeomorphic to M to M. Then we will say these two manifolds are Tn cobordant. Okay.
Manifold is a Tn cobordism,
and this is the Tn cobordism. Yeah. Okay.
Does W have some Tn action?
Yes, this is also Tn manifold. So I should say this is also oriented Tn manifold. Okay, so we are considering oriented Tn cobordism, and there are some many theoretical results about the equivariant cobordism, and this was my PhD work. So when I first learned about the Toric topology, I found that one group in Korea, they work this rigidity problem, and another group in Osaka, they are generalizing the definition of quasitoric manifolds. Just relaxing the condition on the group action. And in Moscow, they are doing moment angle complexes. So what can I do? I was then I thought maybe one person in Fudan University, he did some equivalent cobordism for a small cover. So then I thought maybe I can try the TN cobordism of this quasitoric manifold or torus manifold, because it has very nice effective torus action. So that was my motivation to do these things. So we can ask the question that if M2N is a quasitoric manifold with the delta action, then what can we say about this TN? becomes like triangle with vector 1 0 1 1 1 0 0 1, and from the equivalence relation it is clear that this will give CP2. So at the corner point it will give cone over CP2, so it cannot be a manifold. But what can we do that if we consider a simple polytope, and if we consider the vertex cut of that a simple polytope, that will become simple polytope. Okay. So what do I mean by vertex cut is that delete a suitable neighborhood of each vertex by some hyperplane. For example, here we can delete this portion and here this type of thing. So if we do for each vertex, we will get a simple polytope. And after that, if we give the notation QP, this is P. Okay. Now, if we restrict that relation on QP, that means if we consider QP xi equal to Tn minus 1 plus QP with same restriction, it becomes manifold with boundary, and the boundaries are disjoint union of quasitoric manifold. Okay. So this gives explicit Tn cobordism between some quasitoric manifolds. Okay. No. So for example, here we are getting, if we delete this, so what we will get? 4 CP2 with some action, but this CP2 will cancel because the orientation is opposite, and here is CP1 into CP1. Okay. We will see some other examples also. So this was my construction to give some Tn cobordism between quasitoric manifolds. Okay.
What does this say? You have a CP1 character, some CP1 as a boundary or what?
No. I said from this characteristic data, we can say that CP1 cross CP1.
CP1 cross CP1.
Yeah.
CP1 cross CP1 is cobordant to
0.
0. So that's a boundary, right?
Yeah, that's boundary.
Well, of course, it's
Yes.
here.
Yes, but for this characteristic data, this WQP xi is CP1. This has boundary CP1 cross CP1 disjoint union. This one disjoint union. This one disjoint union. This one disjoint union. This one.
So CP2 disjoint union
minus CP2 disjoint union. Yeah, two of them. So this was the condition. Okay. Maybe we can ask some question here that it has smooth structure, because we can see it as quotient of quasitoric manifold by some nice circle action, and then we can ask whether it has some geometric structure or not, like does it have any stable complex structure, the weaker version, and also almost complex. Okay. So let me So, or maybe we can say this is lemma 1. So MK4 with this T2 action, this is 0. Where MK4 is the Hirzebru surface here corresponding to this data. Okay. For example, for this case, if K equal to 0, then this is CP1 cross CP1, and we have this characteristic data. And if we consider the hyperplane in the middle, so it will give these two CP2 are identified for the opposite orientation. So for K equal to 0, we have done. So if K equal to 1, so I did it by what this called some inductive process, but let me draw this picture. I don't know whether it is. So the idea was that to construct some simple polytope so that we can associate this characteristic data to a vertex, and for other vertices it will be intersection of exactly 3 hyperplane. Okay, and that other vertex should give either CP2 or CP2 bar. So here I associate this one, the 1 0, this is 0 1, 0 1, and that is 1 1. Now we have added 2 facets, this one and that one. But if I associate here 1 0, and in the back side this 1 1, no, in the back side is 1 0, and here is 1 1, then it will satisfy, gives an isotropy function corresponding to this polytope. And if we delete the vertices, so we'll get here CP2. Okay, here maybe either CP2 or CP2 bar, but this at this are opposite oriented, so we can identify them, and similarly for other things. So this will give explicit T2 cobordism.
At the vertices where this characteristic vectors are already, this vector is already forming basis, then you don't have to do the vertex cut there, don't you?
Yes. So
you are doing vertex cut on these all the vertices, right? But
yeah.
if you have
then I don't need.
Yeah. If there's already basis.
Basis, then I don't need it. Yes. If they are already basis, then I don't need that.
In your example, all other vertices are already forming bases, right? Aren't they?
No, because this is CP2, so cone on CP2, so it is not manifold.
No,
the dimension of torus is 1 less.
No, what I'm saying is,
so at vertex it cannot be basis.
All right. Okay.
So for higher K, we just add more facet here, and using this result we can say maybe another lemma. If M M1 and M2, these are two quasitoric manifold, and if we take the connected sum at a vertex, so it will have natural Tn action. If we say that is delta, then this is equal to M2n1 plus M22n delta 2. And this is clear from this. Maybe here is some fixed. Did I say?
If you draw a pair of pens, then
yes, if I draw pair of pens, then it will be clear. So if we delete this point and this point where that connected sum happened, then glue equivalently, then this will give the results. And using these results, we can say that any four-dimensional manifold, so maybe theorem, any four-dimensional manifold with delta action is equal to CP2 with delta 1 plus CP2 with delta 2, or plus or minus, okay, maybe I can say some delta k. So on CP2 there are many inequivalent torus action. That means that are not equivalently homeomorphic. Okay, so this is our result, and I don't know, maybe is it too early? So I tried to find out, so from here what I can say that this set will be a generator, but I couldn't find a minimal basis from this collection. So that may be another question on that.
So the cobordism group, the current cobordism group is
T2.
I mean
The group.
cobordism group. T2.
I think that there is no result to that group. What will be that group for any group? That's why I restrict the category for quasitoric manifold case to get some ideas, something like that.
So he's saying that all these quasitoric four-dimensional manifolds up to cobordism,
we can write this generated by this CP2.
With various torus actions.
Yes, for all four-dimensional, and also for some cases for higher dimensional. And now I have some results for orbifold case, but orbifold we can define for any polytope. So that's why we can keep results for orbifold, but for manifold it is difficult, and for high dimensional manifold also. I don't know. And also for that simple simple polytope, we may ask some other combinatorial questions corresponding to that polytope, because in combinatorics there was some, I have found many article describing the minimum number of top dimensional cell in n-dimensional cube. So n-dimensional cube has triangulation. For all polytope, convex polytope, it is triangulable. And the question was like, what can we say about the number of top dimensional cell in n cube? So similar question we can ask for a simple polytope if each vertex is intersection of n plus 1 facets. And okay, maybe I would like to finish here. Thank you. 감사합니다.
Any comments or questions to Soumen?
Yes. So could you tell me again what sigma means there?
Sigma? What is it?
You mean delta?
Sorry.
Action of T2.
Action of T2.
Action.
So that means this is a covariant cobordism class,
You could,
not a covariant.
yes, this delta is
T2 action.
T2 action.
So that means this is omega G, omega T2 of 4.
4, yes, omega T2 of 4.
Up to what? Up to.
Equivalent cobordism.
So, on CP2,
There can be many actions, many different actions.
Different actions. Yeah,
Listing all this.
we can say about this delta 2, it can be associated to, for CP2, this delta S can be associated to A, B, C, D with AD minus BC equal to plus minus
So then you mean
1.
delta I is determined by characteristic vector?
This, now we can associate this delta I's to this vector. So for CP2, we took
Yes.
a standard vector. So if we change
Then
by ABCD, that means this CP2, and we will again get same copies CP2, but the action on CP2 will change by this
yes.
homomorphism.
You mean that it's
So-
the basis, right? Then
Not equivalent.
so equivariant will be preserving the basis, you mean? I'll ask you better. It's too late. 마무리하시죠.
Thank you very much.
Okay.
그다음 우리